So we'll start off today where we finished up the last day. Just a bit of basic integration before we jump onto some of the harder bits, like the exponentials and the logarithms and the trig function. So if you can just integrate that for me, please. The rules of integration on page 26 in your logbook. Right, what we do here then is, it's 1 over x to be squared, so we bring the x squared up, then it becomes x to the power minus 2 dx. So we integrate x to the power minus 2 is we increase the power, so we get the x to the power minus 1 over minus 1 plus c. This becomes minus 1 over x plus c, just to tidy it up. Right, example 2. Integrate for me integration of the square root of x dx. What's the power for a square root? A half, yeah. So that's x to the power of a half. So that is the integration of x to the power of a half dx. So integrate x to the power of a half, we get x to the power of 3 over 2 over 3 over 2 plus c, and that is, can be left like that then. Right, have a go at this one. Integrate for me 2x to be squared minus 5x. So then integrate this, you get 2x to the power of 3 over 3 minus 5x to be squared over 2 plus c, because there's no definite integrals. By the way, if you really wanted to tidy this one up, you would say 2 over 3 times x to the power of 3 over 2 plus c. They wouldn't, unless they say they want it in a certain format, either one of these is acceptable. Because you're dividing by the bottom fraction, you flip it. So it becomes 2 over 3 times x to the power of 3 over 2 plus c. Right, I'll go with this one. The integration of x plus 1 over x dx. Sorry, that should be x to be cubed. X plus 1 over x to be cubed dx. Right, so just so we know, there's two different ways you can do this. One way is saying the integration of x plus 1 multiplied by x to the power minus 3. That's one way of doing it. Probably the easier way in certain circumstances, though, is x over x to be cubed plus 1 over x to be cubed. You can split them up. Alright, just so you know, there is two different ways of doing it. Do whichever way feels comfortable to you, they're both right. So that's the integration of 1 over x to be squared plus 1 over x to be cubed dx. That's the integration of x to the power minus 2 plus x to the power minus 3 dx. We now integrate them. Integrate x to the squared, you get x to the power minus 1 over minus 1 plus x to the power minus 2 over minus 2 plus c. That is minus 1 over x minus 1 over minus 2x squared plus c. Either way, you'll end up with the same answer. That should be kind of minus minus for plus, and then 1 over minus 2x squared. Right, have a go at the last one of these before we move on to the definite integrals. As I said, it's kind of more of a recap of what we did the week we finished off. The integration of x minus 1 over x to be squared dx. So, first things first, anyway, is square that out before you start. So you can do bracket bracket, or you can do square first, twice the first by the second, or square the last. Either way. Right, as I said, first things first, let's square out our brackets. So probably when it's dealing with fractions, the handiest way to do it is x minus 1 over x by x minus 1 over x. So that's the integration of x by x is x squared, x by minus 1 over x is just minus 1. X is next cancelled. Minus 1 over x by x, once again, is just minus 1 as your x's cancel. Minus 1 over x by minus 1 over x is minus 1 over x to be squared. So that's the integration of x squared minus 2 minus, I'm going to change this into minus x to the power minus 2. Just makes it easier to integrate. So we integrate it in. That's x to the power 3 over 3. Integrate a single figure, you get minus 2x. Integrate this, you get minus x to the power minus 1 over minus 1. That's x to the power 3 over 3 minus 2x, minus by minus leaves you plus x to the power minus 1, which is x to the cubed over 3 minus 2x plus 1 over x to the power 1. If you did it all in one phase, you would probably right the first time. Sorry. Right, let's move on to definite integrals. Oops, obviously we'll have to add on a plus c. You get dropped 3 marks, by the way, guys, if you leave that out. Whenever there's no definite integrals, i.e. whenever there's no number up here or down here, you must add in plus c so we know what the constant is. It's known as the constant of integration. Example number 6. So, definite integrals. I want you to integrate for me 2 seconds. Integrate for me between 2 and minus 2 x squared plus 4x dx. So we're going to be integrating it, subbing in 2, and then taking away what answer you get within minus 2. Don't forget we're dealing with area, so it's absolute values. Right, let's look at it. So, we integrate x squared plus 4x. That's x to the power 3 over 3 plus 4x to be squared over 2. No need for plus c this time because we're doing the definite integrals between 2 and minus 2. That's x to be cubed over 3 plus 2 into 4 goes 2x squared times between 2 and minus 2. So we sub in 2. 2 to be cubed over 3 plus 2 times 2 to be squared minus 2 to be cubed over 3 plus 2 times minus 2 to be squared. Put it straight into the calculator. Two to be cubed over 3 plus 2 times 2 to be squared. Get 32 over 3 minus. Back and change our figures to minus 2's instead of 2's. You get minus 16 over 3. 32 over 3 minus 16 over 3 is 16 over 3 or 5.33 units. You got that, didn't you? Good stuff. Right. Jump on the hard one. Integrate this for me. Integrate for me between 2 and 1, x squared plus x over x to the power 4 dx. So once again, you can bring up the x to the power 4, or else you can just split them up like we did the last time. And you're doing it between 2 and 1. Right, we have a little look at it then. So, that's the integration between 2 and 1 of x to be squared over x to the power 4 plus x over x to the power 4. Once again, you could have brought x to the power 4 up and multiply by x to the power minus 4. So that is the integration between 2 and 1 of 1 over x to be squared, which another way of saying 1 over x to be squared is simply just x to the power minus 2, plus 1 over x to the power 3, which is simply another way of saying x to the power minus 3. We integrate these then. That's x to the power minus 1 over minus 1 plus x to the power minus 2 over minus 2 between 2 and 1. That is minus 1 over x plus 1 over minus 2 times x to be squared between the integral of 2 and 1. So, subbing in your values then. Minus 1 over 2 plus 1 over minus 2 times 2 to be squared minus 1 over 1 plus 1 over minus 2 times 1 to be squared. Straight into your calculator. Minus 1 over 2 plus 1 over minus 2 times 2 to be squared, which is minus 5 over 8, minus, back and change your 2 to a 1, you get minus 3 over 2, so that's minus 5 over 8 minus 3 over 2. What's the problem though? Has to be positive values. So this is 5 over 8 minus, and this is 3 over 2. 5 over 8 minus 3 over 2 is equal to 7 over 8. Right, I've got this one. Example number 8. Integrate between integration in Kn1 of 2x plus 3 dx is equal to 6. Find k. So you do it the exact same way as you did before. But we know what the answer is this time. Is that right? the easiest one there and the last one is if you put the absolute value either side of it and put that straight into the calculator and just know it has to be positive, just so you don't make a mistake on an exact value. Just while you're doing that there, that's 2 seconds. So you're integrating as normal, you're subbing in k, you're taking away your 1, but you know your answer is 6. Find the value for k. Right, let's have a little look at it. So that is integrate 2x plus 3 is 2x squared over 2 plus 3x. 2x squared over 2 is x squared plus 3x between k and 1 is equal to 6. So, don't forget our absolute value is 6. That is k to be squared plus 3 times k minus 1 to be squared plus 3 times 1 is equal to 6. That's k squared plus 3k minus 1 to be squared is 1 plus 3 equals 6. That's k squared plus 3k minus 4 is equal to 6. K squared plus 3k, bring over your 6 and you're going to get minus 10 is equal to 0. What we do? Bracket, bracket. Plus k and k, plus 5 and minus 2. K is equal to 2. K is equal to 5. We check them? Sorry. No, plus 5 minus 2, so that's minus 5. So we check them then. Right, up here you had k squared, so we check 2 to be squared plus 3 times 2 minus 1 to be squared plus 3 times 1. See, does that give us 6? Which is 10, and then 1 to be squared plus 3 times minus 4 does give us 6. Or we check 5 to be squared plus 3 times 5. We know that's going to give us minus 4. See, is that equal to 6? 5 to be squared, minus 5, sorry. Minus 5 to be squared plus 3 times minus 5 gives us 10 minus 4, which is 6. So they both. Is that okay? Right. Let's move on to questions that end in a logarithm function. So, integration of logs. Integrate for me 2 over x dx. Using the rule on 26. So, very, very simple. Left with x in the bottom line. If you bring this up, so the reason this won't work is you have 2x to the power minus 1. If you try to increase that, you're going to be left with 2x to the power 0 over 0, which can't happen. It's undefined. Alright, that's why we can't bring it up and we can't do it. So what we must do is take out a 2 to the outside, and we integrate then 1 over x dx. Alright? What happens there then is that's 2 times integration 1 over x is simply just the ln of the absolute value of x plus c. So it's 2 ln of x plus c. And that's the answer there. Alright, so whenever you're left with just an x on the bottom line, you know it's going to be logs. So just an x on its own on the bottom line, you know for a fact you're going to be left with a log. Is that okay? Right, have a go at this one then. Integrate for me x plus 2 over x dx. I told you there's 2 ways you multiply and split. Sometimes splitting is the easier way to go. Right, let's have a little look at it then. So that's the integration of x over x plus 2 over x dx. That's the integration of x over x is 1 plus 2 over x dx. You integrate 1, you get x, take out a common 2, and you're left with 2 over 1 times x dx, which is x plus 2 times the ln of the absolute value of x plus c. That okay? Right, have a go at this one for me. Integrate for me between 7 and 2, 3x squared minus x over x squared dx. So, logs, the definite integrals. Let's go on here and jump on into exponentials and 3. So, integrate is normal first of all, then worry about the definite integrals. Just yourself, just you know the argument, because you don't make a mistake if you don't have. As I said again, guys, I am really sorry about eating the room. I'm feeling it myself. It was working fine, and just decided to blow. Just for the flat. So you know that. You see that, yeah? What that is on top, I was saying something to break it out right. So, boom, 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 boom. That's what should happen there. Once again, x over x squared, that's x over x by x. So once again, you're left with 1 over x. Alright? Sometimes it's easy to just break it out your head like that. See how much to do. Right, let's have a little look. So, integration between 7 and 2 of 3x squared over x squared minus x over x squared dx. That is the integration between 7 and 2 of 3 minus 1 over x dx. Integrate the following, you get 3x minus the ln of the absolute value of x between 7 and 2. So that is 3 times 7 minus the ln of 7 minus 3 times 2 minus the ln of 2. You're getting the absolute value of that. So that is 3 times 7 minus the ln of 7, which is 19.054089 minus, you do change them to 2's, minus 5.3068, 19.054089 minus 5.3068, and you get a final answer of 13.747289. Right, integration of trig functions. Integrate for me the cos of 2x dx. Once again, rules are on page 26. Unfortunately, this isn't in the logbook, and I know what you're trying to do there, which are small that we're on. So, important thing to do in the top right corner, because it's not in your logbook, just so you're looking at. You're integrating the cos of ax. That is the great cos of sine of minus 10. the sine of ax over a. Alright? The sine of ax over a. So finding out what you modifier that you got with this. And it's the same thing with the sine. The sine of ax integrated and you get the minus cos of ax over a. Handy little thing to have in your log. Unfortunately, you're not allowed bringing your own logbook to the exam seat to just try to remember it. No, it's actually that's considered what you're actually doing is when you integrate cos, you get sine, and you integrate the a of x of it, it's over a. That's actually considered integrated. Good question. So for this then, we integrate cos, and we get the sine of 2x over 2 plus c. And that's the answer. Right, have a go at this one. Integrate the sine of 5x dx between 3 and 0. Right. So we integrate this then, and we get the integration of integrate sine, and we get minus the cos of 5x over 5 between 3 and 0. So that should be integrated already. So that's minus the cos of 5 times 3 over 5 minus the cos of 5 times 0 over 5. Enter our calculator. Minus the cost of 5 times 3 over 5. And you get 0.1519 minus, change it back to zeros, and you get minus 1 over 5, absolute value, put them to them into your calculator, 0.1519 minus 1 over 5, and you get minus 481 over 1,000, but it's the absolute value, so it's 481 over 10,000. That's your answer. Don't forget, it's always absolute value. Right, have a go at this one. Integrate for me the tan of x over the sec of x dx. Nearly there, guys. Only about 20 minutes left. So the tan of x over the sec of x dx. Yeah. Yeah, because you would put a different figure in. I never said walk around. Would you put in minus the cost of 5 over 3 over 5? Check mine. I could be wrong. My fault. Work this thing. I have it in red. Yeah, you got negative 0.1931. Yeah. I had mine in red. Thank you very much. Little note to learn there, always make sure your calculator is in the right mode. Minus 0.193185. Minus 1/5. Negative 0.193185 minus 1 over 5 is negative 0.3913, but it has to be absolute value, so that should be 0.393185. Thank you. Right, this time, when it comes up a bit like this, use trig rules before you integrate. So, use a few trig rules before you integrate. I.e., simplify it. I'll try simplify it before you integrate. Don't try integrate tan and integrate sec. So use our log. When it comes to integration and trigonometry, you should always be flicking between like page 26, which is integration rules, and 13, 14, and 15, which is your trig rules. So you should always keep an eye on when you're integrating a trig, you might have to jump back to trig rules. Simplify these. It kind of works for anything, but differentiating trig is like you do the same thing. See if you can simplify the trig before you integrate and differentiate. Right, have a little look at it. So that is the integration of the tan of x. Another word for another way of writing the tan of x is the sine of x over the cos of x divided by sec, which is 1 over the cos of x. So we're integrating the sine of x over the cos of x divided by 1 over the cos of x, which is the sine of x over the cos of x multiplied by the cos of x over 1. Flip your second one. That knocks, that knocks. So that's the integration then of the sine of x. Integrate sine and we get, is it cos or minus cos? It is minus cos of x plus c. Minus the cos of x plus c. Right, have a go at this one. Once again, we're going to use a bit of trig on it. Integrate 2 times the sine of 4x by the cos of 2x dx. Right, you cannot integrate the product. You cannot integrate the product, i.e. 2 and 3 multiplied by each other. So it's using trig rules. Split it and then integrate it. So once again, we go looking through our trig rules. This is back to a bit of trigonometry we did before with product and compound rules and the sum and product. So if I just give you a hint, I'd say page 15 and 14. Cannot integrate with this product. We must do something with it. Right, I think we're fairly on the right line. This might need a few little touch-ups. So, first things first. The integration of 2 sine of 4x cos of 2x. We go to page 15 as we said. That's sine and cos. So 2 times sine and cos is the rule of 2 times the sine of a plus b plus the sine of sine and cos plus the sine of a minus b. So 2 times the sine of a plus b plus the sine of a minus b. So that is, sorry, that 2 should be gone then. That is the integration of the sine of a, which is 4x, plus b, which is 2x, plus the sine of a, which is 4x minus 2x. That's the integration of the sine of 6x plus the sine of 2x. We integrate the sine of 6x, integrate sine, and we get minus the cos. So that's minus the cos of 6x over 6 plus integrate sine, we get minus the cos of 2x over 2. Right, slightly harder one. Have a go at this. Integrate for me. Near there, guys. We'll finish up there in 5-10 minutes. The integration of the sine of 3x by the sine of 5x dx. What are we thinking? Just go through the rest of the questions. So remember, we do big rules. Very important for trigonometry as well. You bring it half to the outside. This is no 2 in front. So it's half, and then it's just the same thing again. It's just your sine by sine. Because there's no 2 there, it's a half. Is that right? don't forget, sorry, as well, plus c on the last one, because there's no definite integral. Right, let's look at it. So then, that is a half times the integration of sine and sine is the cos of 3x minus 5x minus the cos of 3x plus 5x. So that's a half times the integration of the cos of minus 2x minus the cos of 8x. That is a half times, right, integrate cos, leave your half on the outside, integrate the cos of minus 2x, and we get the sine of minus 2x over minus 2 minus integrate cos again, the sine of 8x over 8. Is that okay? Right, last question. We'll finish up at 20 past. We'll make up the time another day because one of the three of us is going to freeze anyway, first of all. So we'll finish up with this one. Example number 15. Integration of exponential functions. So integrate for me e to the power of 2x plus 3 dx. And don't forget your plus c up there. Once again, the rule is there on page 26. So simple as this, integrate e to the power of 2x plus 3 is simply just 1 over 2 times e to the power of 2x plus 3 plus c. So exponentials are handy enough to, it's the same thing, it's just you integrate whatever the x value is, like that. There's maybe one more practice of those. Example number 16, I've got this one. Integrate for me e to the power of 3x minus 1 dx, in between the integrals 1 and minus 1. First things first, integrate e to the power 3x minus 1, that's 1 over 3 times e to the power 3x minus 1 between the integrals of 1 and minus 1. That is the integration of a third times e to the power 3 times 1 minus 1 minus a third times e to the power 3 times minus 1 minus 1. That is the integration of a third times e to the power 3 minus 1, which is 2, minus a third times e times 3 to the power minus 3 minus 1 is minus 4. You happy with that? Fire straight into our calculator. 1 over 3 times e to the power of 2, which is 2.4630187 minus that, which is power 10 minus 3, that's 0 10 to the power minus 0.00610.521, 2.4630187 minus 0.0610521. Get a final answer of 2.4569. Okay with that? Right. Good class, guys. We finished up there about 5 minutes early.